Yes, good morning. Uh, we would continue our discussions with the rock cycle. If you can remember last, we talked about biochemical and organic rocks. So today we'll talk about something else, which we call metamorphic rocks. If you see here, these are some of things that we use at home on a regular basis. These are all made from soil which was molded together, and then later it was subjected to intense amount of heat, which eventually ended up changing uh, the the minerals basically that makes up such materials. So that is the same thing with tears. It's the same thing with clay pots and so forth. So it basically means earth materials or rocks can change from one form to the other as a result of uh, heat. If such materials are exposed to an intense amount of heat and pressure, it starts changing its structure. So, and that process is what we call a metamorphosis. So, which basically mean it's rocks that have been changed from one form to the other. So it means it's rocks that were either sedimentary rocks, but because they were subjected to some kind of heat and some pressure, they ended up changing. And that is exactly the same thing that happens here, because for this to form, it need to have be first it will be molded, but then later on it need to be subjected to an intense amount of temperature for it to change. So now, as a result, uh, metamorphic basically mean changed from an original parent material, right? A rock that has been changed from an original parent uh, material. If you look at these two word, if you look at this word metamorphic, you can divide it into two. You have meta, which means change. Then you have morph, which mean form or shape. So it basically means changed from one form or shape to the other. It's very important for you to understand that. So now it means such rocks changes from their parent rocks. Parent rocks, what original made such rocks up. So now the parent rocks are what we refer to as proteroids. And metamorphism can occur to any kind of parent material. It could either be sedimentary rocks, or it could be igneous rocks. All those can change. So now this is kind of change, something changing from one form to the other, but that change is occurring in a solid state, right? Change occurring in a solid state. So these rocks eventually becomes more and more harder, much more harder than what their parent materials were. Now, this change does not include, for example, weathering processes. It does not include refication processes. It also does not include melting. So it basically uh, refers to that uh, change from one form to the other, whereby the rock become even much more harder and even much more compact. And that is indeed what happens when these are being bent to make them much more harder. So that's very important for you to understand. Now, so once such changes take place, the parent materials or proteroid undergoes changes. It could be changes in terms of texture, or it could be changes in terms of minerals, right? And such changes uh, occurs because of changes in physical or chemical conditions that are being brought about by things, for example, burial. For example, we have talked about uh, uh, rocks being buried underneath because of materials that are being deposited on top of each other. So that burial uh, increase the amount of pressure, right? So that barrier increase the amount of pressure underneath. So eventually, the texture and the minerals of such rocks start changing much more bigger than what rectification as a process would bring about. It could also be physical or chemical conditions that are being brought about by tectonic stress, right? Tectonic stress, when you have, for example, uh, lifting taking place, or you have movements of plates taking place, and such movements uh, start mounting pressure inside the rocks. So that brings that friction. So you have tectonic stress that is coming up, and that tectonic stress would start generating heat, right? So it will start generating heat and pressure. And when that happens, you expect that such rocks uh, will start changing their texture and minerals. The other issue is heating by magma. We have talked about how magma intrusion can come from uh, well, from the earth mantle, and that magma would try to penetrate through the upper part of the earth interior so that it can eventually explode. So now I have talked about a part of magma which get to solidify within the earth interior. So it means that magma, when it solidify within the earth interior, all the rocks that are being heated by this magma because it's so hot eventually would start changing their texture and their mineral, converting them from either igneous or sedimentary rocks to a much more compact, a much more harder metamorphic rock, if you like. What you have here is an example of how burial, for example, materials that are being buried beneath starts changing. So you see, for example, time A, you have sediments that are being deposited on top here. These sediments would start piling up. Then later on, after so many times, the amount of sediments that have been deposited uh, have increased even more, from a thickness of 2 kilometers to as thick as 8 kilometers. So it would now mean anything that is below here would now be subject to a much more intense amount of temperature. So is pressure. And then give it more time. For example, it could be after some millions of years or so. So give it more time. Deposition would continue taking place such that now the thickness of this deposited sediment has increased so much to 12 kilometers. So now the layer which was deposited first, right? The layer which was deposited first, now temperature is some 240 Celsius degrees. So the layer which was deposited first, because of that temperature and the pressure, would start changing to something else. It would start becoming more and more harder because there is so much pressure that is being brought about by the layers that are on top. So is the temperature. So that is how the burial of materials can bring about metamorphic changes in rocks from one form to the other. The other important thing for you to understand is really tectonic stress, right? tectonic stress, well, uh, as you well know, the continent is made up of several landscapes, and it's made up of tectonic plates, and those tectonic plates keep on moving, right? So it's a dynamic planet. So that movement can build uh, that movement can build stress within inside, and at one point that stress could even uh, for example reach a boiling point such that you will have an earthquake. But you see, for example, here, suppose these are sedimentary rocks in layers, right, in several layers, depending on the time each layer was deposited there and the source of materials that it came from. So layers piling up on top of each other. Should there be tectonic stress of some kind here, you expect that now this would become deformed. You see here, it was deformed because everything was just nicely piling up on top of each other. But here, because of that tectonic stress, now everything is deformed. And I'm pretty sure many of you have seen landscapes. For example, those that have been in window have seen landscapes that are being folded like this. So all that is because of tectonic activities that mount pressure such that now these rocks start changing their structure. They start becoming more harder and harder. So eventually this would no longer be a sedimentary, this will no longer be sedimentary rocks, but would have been changed to something which is called a metamorphic rock. They would have been become more harder and more compact. So that's very important for you to understand. When we would meet, again, we would talk about the geothermal gradient and how heat plays an important role as far as metamorphosis is concerned. Thank you.